Presentation on paper title, breast cancer detection and classification using deep learning techniques based on ultrasound image. Paper ID 8397 by Abdulqader Mohammed Khalaf, Department of Mathematics and Computer Science, Faculty of Science, Al-Azhar University, Nasr City, Cairo, Egypt. Under supervision of Prof. Dr. Mohammed Abdel Razek, Associated Prof. Dr. Mohamed El-dosuky, Dr. Ahmed Sobhi. Outline: Introduction, Problem Statement, Related Work, Contribution, Proposed System, Results and Discussion, Conclusion and Future Work. Introduction: Breast cancer is a common type of cancer that forms in the breast cells and is more common in women than in men. Early detection of breast cancer is essential for effective treatment. A breast cancer diagnosis faces several challenges: false positive, false negative, dense breast tissue, irregularity boundaries of tumor, especially malignant tumors. Problem statement number 1. Breast tumor do not have a fixed size or location, especially malignant tumors. Number 2. Change in shape and difficulty gate masking the tumor or identifying only the tumor's area, especially malignant tumors, while benign tumors have irregular or semi-regular shapes. Number 3. Some nodules or clusters that could be interpreted as tumors, but in reality they are not. In some cases, there are more than one tumor's mass in the same area. In this case, a mask must be taken for each tumor mass separately. Related work. This is a related work table which summarizes the related work into reference and description of the method. We note the majority of approaches utilizes deep learning methods. Contribution. Contribution can be outlined as follows. Number 1. This paper proposed a deep learning model that increased the accuracy of detection and classification of breast cancer from ultrasound image. Number 2. The proposed model outperformed previous work, reaching 99.29% accuracy. Number 3. Many features have been extracted thoroughly in detecting and classifying the type of tumor in a high and efficient manner. Number 4. The proposed system was trained on masks for the tumor area and was tested on images of tumors. So the system detected masks for these images, and the systems also made masks for images of tumors that were not trained either on images or on masks. Proposed system: dataset, pre-processing, in first phase, pre-processing. Pre-processing in the first phase is pre-processing. Pre-processing the image to remove of noise and improve them by applying the filter to them. Their resizing, enhancements, and adaptive thresholding. Phase 2 is segmentation. Image segmentation is a digital process that divides an image into multiple segments. The unit model a group of CNN, fully convolutional neural network, designed for biomedical image segmentation and segmenting objects in a digital image. In the third phase, feature extraction. Feature extraction process that reduce the dimension of raw data into manageable groups and decryption the original dataset, especially in large data. This work also includes feature extraction for tumor contours. Mobilenets is a low-cost, efficient convolutional neural network (CNN) used for mobile vision tasks like object detection. In mobile nets, the depth-wise convolutional neural network applies a single filter to each input channel. The feature as using such as perimeter, width, height, area, aspect ratio, and etc. In the fourth phase, classification. Finally, the fourth phase, classification. Classification models uses utilizing transfer learning with a VGG16 models that has been pre-training model. The pre-trained layers are frozen, dividing the data into 80% training set and 20 validation set. The VGG16 model is 16 layers convolutional neural network CNN architecture, known for its exceptional performance in a computer vision tasks. The network fully CNN layers and softmax for output. The model consists of latent layer, dense layer, sigmoid activation function. It has been trained on a dataset containing X-ray images classified as either benign, malignant, or normal. After training, the actual and predict mask comparison. Model, test train, build model, train model, evaluate model, accuracy. Dataset, data collected at baseline, which includes breast ultrasound image for women aged 25 to 75. Dataset obtained from Bahia Hospital for early detection and treatment of women cancer in Cairo, Egypt. Divide three classes: normal, benign, and malignant images. Normal, benign, malignant. Sample of ultrasound image breast. Result and discussions. Evaluation. Evaluation using number of parameter and variable such as confusion matrix including true positive, true negative, false positive, false negative. We have accuracy, recall, precision, sensitivity, specificity, F1 score or F measure. System walkthrough. The figure shows the output of pre-processing stage. Input image, bounding of region of interest ROI, and output of ROI zoomed. The figure shows real image, mask of a tumor, and mirror of mask of a tumor. The table shows training parameters, e-books, batch size, and learning rates, accuracy, loss, AUC. Accuracy is measures the model ability to predict correct label or classes for training data. Loss measure the between predict output and actual labels in training data. AUC area under the curve using binary classification task measure and evaluate the model performance. The figure shows explain the loss of training data. Figure show main image, predict mask, and real mask. A mask in computer vision is a binary image that indicates specific regions or objects of interest used for object segmentation or image annotation. Real mask as manually annotated, representing the true segmentation of objects or regions, while predict masks are generated by AU models or algorithms. The table show the layers, parameters, and output shape of VGG classification. Layer, flatten, batch, normalization, dense, total parameters, trainable parameters, no trainable parameters. The table show testing parameters. We have epochs and batch size and learning rate, accuracy, validation accuracy, loss of testing. Loss started. Figures show classification model performance. Loss started 1.4 and decrease to reach 0.0453, while accuracy started 80 and reached 99.29. The figures show ability to propose system detect if an image belongs to which class, to be normal, malignant, or benign. The figures show only those pictures that are predict false. Rest of the pictures are predicted true. It's just for classification of the results. The figure shows the confusion matrix: true positive, true negative, false positive, false negative. Confusion matrix representation that show the predict and actual classes label for a set of data. It consists of four key elements: true positive, true negative, false positive, false negative. The table shows list of measurement of robust system: precision, sensitivity, specificity, recall, and F1 score or F measure. The table shows the comparison. The proposed model exceeds the previous model in accuracy. 99.29 is proposed system. Conclusion and the future work. This paper tried to present a proposed system for detecting the presence of breast cancer and classifying it by type based on ultrasound image of the tumor. The results showed that the proposed system was able to detect and classify well compared to previous work that worked on the same database, reaching accuracy of 99.29%. The paper recommends that in future work, researchers shall be able to apply other techniques in deep learning, create a hybrid system of combination of methods, techniques, and compare them, and can also be applied to other databases. List of references, introduction and related work, previous work. Thank you.